So welcome students. In this video we'll be graphing exponential equations. And exponential equations look like what we have here. It is y equals 5 times the quantity of 3 raised to the x power. X is now an exponent, and to graph this, the first thing we have to do is create a table. And with an exponential equation we have the left-hand side is the domain. It corresponds to the x's. And then the right-hand side is the range. It corresponds to the y's. Now sometimes, most of the time, we're going to be using the values of a -4, -3, -2, -1, 0, 1, and 2 for all our x's. That's going to be standard. Sometimes we'll have to go a little bit lower than that, like maybe a 3 and a 4, but those first 7 values right there, that's mostly what we'll end up graphing. Now to graph these, we'll take the x's, we'll put them in our calculator. So we'll type that equation into the calculator, and then the x's go in for the x's. Now there's another symbol we have to use. This is called an up caret key. And so we'll type in 5 times the quantity of 3. We use our up caret key, and it symbolizes that that next number after the up caret key will be an exponent. So once we type everything into our calculator, we'll fill into the right hand side of our tables with the y values, and then we'll go ahead and take those values and graph them onto the table. So you can see here that I've graphed it. It gives it a nice gentle curve. There's the -4 that I start with. It goes up, and then I go to the -3, -2, -1, 0, and then those other values of 2, 1, and 2. Now what you notice about the shape, it's a nice hockey stick shape, and this is a classical shape that we get with an exponential equation. There's a couple of other things we're supposed to ask to find. We're supposed to find the y-intercept, and this is a way that we can check to see that we've graphed it correctly. The 5, the first number, is always the y-intercept. You should see a 5 there. You should see 5 where it crosses the y-axis. You can see there's the y-axis right there, and it crosses at 0 on the x and 5 on the y. And that 5 should also correspond to 0 in the x and 5 for the y when we create our table. So you should see that in 3 places. You should see it 5 in the equation, you should see it on the graph, and you should also see it in the table. Now the last thing we're supposed to find is to decide if our equation is growth or decay. And the growth factor is that 3 that's found in parentheses, so that's always a growth factor. Okay, now the next thing we're supposed to find is we're supposed to decide if it's exponential growth or decay. Decay goes down from left to right, and the one that we see how that should go down from left to right? It's just opposite of what we have. And if it's growth, it should increase from left to right. And so to give our answer for the type of graph that we have, we can see that it's exponential growth because it's increasing from left to right, whereas if it was decay, it would decrease from left to right. So that's just a quick run through of what we're doing as we graph exponential equations. And so thank you for watching, and we'll see you in the next little section of this video. Welcome students. In the next part of this video, we'll be graphing the equation that we started with here, and so we need to get out our calculator, and we know we'll be graphing y equals 5 times 3 raised to the x power. And again, we start by creating ourselves a table. We'll go ahead and type in our equation, 5 times 3 raised to the x power. Make sure you use your up caret key, and our first exponent is a -4. There we go. Make sure you use the negative key and not the subtraction key. So our first value is 0.061. I'll round that 1 off to a 2. Now we'll go up and edit our equation. We'll change that 4 to a -3. Edit it. Now I have 0.185, rounding off to 3 decimal places. And I wouldn't be too concerned about rounding it off correctly, because when we get further into the video, you'll understand. Okay, here, change that -3 to a 2. And I get 0.555, so I'm going to round it off to 0.556. So that's just barely above a half. Now we'll try a 1. Now that 1 is between, I have 1.66, so it'll be 1.67. That's just between 1.5 and 2, right? So it's between 1.5 and 2. Just think about when I'm going to have to graph this. Now I put a 0 in here. Now remember, 0 is important because this should coincide with the 5 that we get from the equation. It has to be the y-intercept. And so at 0 I have a 5, and it matches that first number in our equation, so I know I'm graphing my equation correctly. Now the next one, I'm going to change that to a 1. And here I get another significant value. I get 15, so the numbers change quite a bit from those decimals to nice integer numbers. And now I put a 2 in there, and I get a 45. Now that 45 is off the graph because my graph only goes up to 20. All right, so now we have all our domain and our range. Remember, the domain is the x's, and the range is the y's. Now if we look at these values right here, they're very, very small. At a -4, that's just barely above 0. At a -3, it's just barely above 0. So those values there are very, very small. And then a -2 is a little bit above a half, and a -1 is just between 2 and 1, more closely to 2. And then we get nice whole numbers for our next 3 values. So those shouldn't be too bad to graph. All right, let's zoom into our coordinate plane and let's begin graphing this. Now at a -4, it's just barely above 0. There's 0 on the y-axis, so just barely above 0. Now that should never go below 0. You should never have any values that go negative on the x-axis. The L should be positive. Now to -3, I can just go up a little bit farther. -2 should be right at a half. -1 should be at up 1, and then a little bit above a half, because 1.6 is just a little bit above 1.5. And then there we have our y-intercept like we talked about. At 0, it should be 5. Now you can see this nice gentle curve that we should end up getting, that hockey stick shape. And then at 1, I have 15. Now 45 is off the graph, so you really can't put that point, so just leave it off. Make sure you still include it on your table though. Now to finish this, we just take a straight edge and we just connect our dots. We know at a -6 it should be even smaller than a -4. So I'm going to start just barely above 0, and all I'm doing is connecting those points with a straight line. So a good way for you to do this is just to take a piece of scratch paper, fold it about 3 or 4 times together, and make yourself a nice little straight edge. And then you just draw straight lines between each one of those ordered pair that you have plotted on the coordinate plane. So there's our nice hockey stick shape. We know our graph is right. We can see the 5, and the 5 on the y-axis. So we've put the numbers down correctly. Okay, let's answer the rest of our questions. We have the y-intercept. We've talked a lot about it. It has to be at 5. We've got those 3 5s. So the y-intercept is 5. The growth factor, remember, is a number, the second number. It's being raised to the x power, so that one is 3. And then now we have our exponential growth shape. It increases from left to right. Remember, if it was decay, it would be going down from left to right. So it is exponential growth because of that increase from left to right in our hockey stick shape. Okay, there we go, and thank you for watching. There will be another section of this where we do a different problem, so just hang in there and you should be done.